Hi, it's the 6th of August 26. I'm making this video about the energy transition and focused on um, electricity. Now, I made a really simple graph. I want you to, can you see that? That's a very simple drawing that you have here. I'm not really very good at this. Let's see if I can see that. So here, this round thing is a copper wire. And there are two wires coming out of this coil, this copper wire coil, a plus and a minus, and here's the bulb, which is shining. Now, inside this copper wire, there is a magnet on a stick. And as this stick turns, it turns the magnet, and as the magnet turns inside the copper coil, it produces electricity. Now, there are two ways to make this stick turn. Like this is the watermill version. You just put like big shovels around it, and when you throw the water on top, it's gonna make the stick turn. Or you can put like wind blades on it, and the blades turn, and that turns the stick. So here's the turning. So basically you have a stick with the magnet at the top, inside a copper wire, and the stick is turning. The stick is turning the magnet all the way round, and as it turns round, out comes electricity. Now if you turn the stick and it turns inside the copper wire, you get electricity. If you turn the whole thing around and you put the electricity in, which makes the magnet turn, which makes the stick turn, you suddenly have an electro engine. Because in an electro engine, you put electricity in one end and you get a turning stick at the other end. And this turning can be attached to a wheel of a car or the wheel of a pump or anything else. And that is the basic mechanism of making electricity, which has been for the past 200 years. Now, in my drawing, I have drawn wind blades and like these wooden pieces where you throw the water on and it starts turning. But actually, let me just do that. Let's see if I can make this happen. How do I make flames? So the most basic thing, which started with a steam engine, is here you have flames who make a fire, who heat water that turns into steam, and that goes into little blades, and it turns the blade, and the blade turns the magnet. Can you see that? So it's all very low tech this, but the basic principle is the same. You take a bucket of water, you put fire underneath, and you heat it so the water starts boiling. Then you gather all that steam in the pipe, and steam starts pushing up. And then you put a little blade, like a windmill, a blade that turns in the steam that goes up. And as the blade turns, it turns the stick. because the whole thing is you have a stick with a magnet inside the copper coil, and as you turn the stick one way, you get electricity. So the whole thing is about turning the stick. Anyway, so, and if you put electricity in, you make the magnet turn and you make the stick turn. So this energy of the turning stick, you can use. That is the idea of electric motor, which you can make a wheel turn or anything, and you can take the turning into another kind of motion, an up and down motion or a sideways motion. And this is basically when you take the steam engine, that is the principle of the steam engine is you don't use the part where you create electricity, but you turn the stick. So when you turn the stick, you turn the wheel of the train, and the train moves. So you have these two things: the steam moves the stick, and the stick turning around a magnet inside the copper coil will produce electricity, and then you reverse the whole project. Now, just look on YouTube, and you get really very nifty, beautiful drawn or AI generated models, which explain this to you a lot better than my very crude drawings. So have fun with that. I had fun with that. That's how I know this. And this, for 200 years, we have made electricity this way. Copper coils, magnet in the middle, turn the magnet, turn the stick. So when you look at all kinds of mills, like windmills, water mills, but also water generated electricity, which is they're all based on the same principle of turning the stick. And there are different ways of turning the stick. You can turn the stick with blades in the wind. You can turn the stick with blades in a stream, in a river, in water. But you can with hydro energy, you put a lake at the top and a tube which goes down the hill to a lake at the bottom. And inside the tube, you place blades. And when you pour water from the bottom to the top, it makes the blades turn, which again turns the stick turns the magnet inside the coils and creates electricity. And now you think it can't be that easy. Yes, it is that easy. Once I got the gist of it, I thought we've been doing the same thing for 200 years. It's amazing. So anyway, and then you say, yeah, but what about nuclear energy? Well, that is just a steam engine. You know, like I said, you boil the water and the steam goes into a tube and gets compressed, and that turns the blades inside the tube, and the blades turn, and that turns the stick, and that turns the magnet, and that produces electricity. So, and then you say, what's nuclear about it? Well, the way you heat the water. You know, we have all this technology, and all we're using this uranium and technological technology about nuclear is just to make water boil. because uranium gets hot when it is in a reaction, in a nuclear reaction, and that heat warms the water and heats the water and creates steam, and it's just a uranium nuclear steam engine. Instead of burning coal or gas or oil to heat the water, to create the steam, to turn the stick, you heat the water not with fossil fuels, but with nuclear fuels. But the whole thing is just boiling water and using the steam and compressing the steam, and then they have blades inside the tube, forcing the hot air, the steam, past the blades, making the blade turn. And as the blades turn, they turn the stick. And these blades turning, we call that a turbine. But it's basically blades turning, making the stick turn with a turbine. And that design hasn't changed since the first water mill 8,000 years ago in Mesopotamia. Only we didn't know how to make electricity. The part about the magnet turning inside the copper wires, that's about 200 years old. So, 100 years old. Oh, forgive me. Anyway, so that's the basic way to make electricity. Turn the stick, turn the magnet inside the coil, copper coil, and you get electricity. So what's the problem with that? Well, copper is getting more and more scarce and more expensive. And there's just not copper enough in the world to build all the electrical motors we would like to build to replace fossil fuels with turbines and electromotors. That's the problem. So with all the electricity we need and all the increase in electricity we need, we're going to run out of electric motors. So apart from heating the steam and turning the stick, we also do not have enough copper and magnets, because magnets are made of rare earth. We do not have enough magnets and copper in the earth to build all the electrical motors we would like to build to electrify our society and to make all the more and more electricity we're gonna need. Because if the cars don't run on fossil fuels and they run on electricity, we need more electricity. And if the factories are not gonna run on oil, but anyway, so the energy transition, especially the electrification of a lot of the internal combustion engine, for example, which we use not just for our personal cars, for trucks, for drilling material, for building material, for factories, etc., etc. So the engine, which is making the movement, we just don't have enough copper and magnets to replace all those fossil fuel engines, internal combustion engines, with electromotors. We don't. We're already running out of copper. So that's a problem. So we can build, so there are plans to build a huge amount of windmills, which is turning the stick, and hydro plants and even nuclear plants, but we don't have the copper and the magnets, let alone all the concrete and all the other stuff we're going to need. So that's a real bottleneck. So making the electricity with a magnet and copper is reaching its limits. And there is another reason why windmills are extremely, well, two reasons why windmills are not renewable or cheaper than fossil fuels, and certainly not environmentally friendly, and it uses more CO2. And that is because windmills use a lot of materials that have to be mined and refined, and the gearbox. Because gearboxes are a real problem. You see, the stick moves the magnet inside the copper coil. You only get electricity when you reach a certain amount of RPM, revolutions per minute. To put it bluntly, the stick has to turn really, really fast. But have you seen a windmill? The blades go whoosh, whoosh. And you need to, for an electromotor, you need to get a 3000 RPM, which is the I can't even show that to you. So how do you get from whoosh to woo? Well, a gearbox. And these gearboxes are like a row of 10 houses. They're that big. You don't see it up there, but they're huge. And there are all kinds, and a gearbox is just a turning wheel and a turning wheel and a turning wheel and a turning wheel, and it goes from bigger to smaller to etc., etc. It's a whole row of turning wheels, which goes from 1 RPM to 5,000 RPM. The only trouble is it's humongous. It's made of steel, and it's heavy, and it's big, and one has to grasp into the other and to the other, like the gearbox in your car. So there's a huge amount of strain that is put on this gearbox, and it accelerates with every turn. So these things tend to catch fire, basically, because you're turning and turning and turning and turning and turning metal plates, and they become very hot, and the whole thing burns to a crisp. So the lifespan of a windmill with a gearbox is a lot less than the 20 years they say it. And it takes a huge amount of maintenance, because you have to go up there, because if even one of those plates is even slightly unaligned, it's gonna scrape against the other, and that means, fire. It's gonna get hot. If one metal plate scrapes against the other, it's gonna get hot. I've seen numbers where the average lifespan with all the fires is 7 years. So when you take all the materials which use a huge amount of fossil fuels and emit CO2, and then all the pressures, and the copper is getting precious, and the gearboxes are on fire, and the maintenance that has to be done several times a year. Windmills are not renewable, and they don't reduce CO2, and they're very expensive, and the electricity you generate is about twice as expensive as if you just burn gas and oil and use an electromotor to spin the magnet, or use the gas and oil to heat water to spin the turbine to spin the magnet. But there are some windmill designs. I'll name two. You have the windmill which is vertical, which is turning like that, the blades that are turning around like that. So at the bottom you have the gearbox and all the electrical components, so you can just drive up and fix it. You don't have to go 300 meters up there. And they're very practical at sea as well, because all the weight is at the bottom. You have this thing which actually floats and doesn't need a base, it just needs anchors. And because all the weight is at the bottom, it'll just keep stable. So smaller vertical windmills are very effective at local power plants at sea, and also in rural areas to go off grid, because they're very simple. Now, and then there's the windmill with no blades and no moving parts. It is actually like a sail, and what it does, it vibrates, because it's like a wing of an airplane, and it's made in such a way that on one side the air moves quicker than on the other side, and you don't get lift because you're vertical, so it just moves the blade in a vibration, and this vibration movement is turned into a turning movement, which turns the magnet inside the copper coil and produces energy. Because all you have to do is turn the stick. But again, the problem is we're running out of copper and we're running out of magnets, and electromotors work in reverse. You put in the electricity, you get the movement, a turning stick. So all that is nice, but it's not a real solution to our electrical problem. Now, so solar panels are really great because they don't use copper wire, magnets, and a turning stick. In fact, the plates, let's just say plates of glass, and they put iron wires in them. And I'm not gonna, I can't even explain it to you, but because of the UV radiation, not just the heat is a byproduct. The radiation are ions which are bombarding these metal strips, and that makes the neutrons move inside the metal strips. And if neutrons move along a wire, that is electricity. If you want to know more, Google it on YouTube, electricity for dummies and stuff like that. And they have wonderful little films and animation and that show you that. But what you have to remember about solar panels is they're panels in which there are copper, in which there are wires, and the ions, not the heat, the ions, the radiation from the sun makes the neutrons in the wire move, and moving neutrons in a wire is electricity. So out of two sides of you get a plus and a minus, and there's your light bulb. The byproduct is heat. And that is a problem. But they're working on that. And it could even be an asset, because all this heat can actually boil water or warm your house or warm your water, etc. So it's not a total waste. Anyway, the problem is that solar panels are not very efficient, but they're getting cheaper by the minute. Now, the problem with solar panels is that the sun only shines a few hours a day, which means that you need batteries. You need to store the energy during the day to use it in the night. And that is why solar power is not a viable, is not renewable or a CO2 friendly, and the batteries use all kinds of precious metals that we're running out of. We simply do not have all the materials on the planet to build so many batteries. And even though they're constantly evolving and trying to change the materials in the batteries, etc., still, if you want to replace the 10 terawatts of electricity we use each year and build 5 terawatts of batteries, even half, there's just not enough on Earth. There's not enough in our solar system to build so many batteries. So, and the transformer. Because the electricity coming out of the solar panel is not the electricity that comes out of your wall plug. So manipulating the electricity so it gets to 220 volts in a wall plug, and storing the energy during the day so you can use it at night. Well, that is what's holding back solar energy and why it's not a viable alternative to fossil fuels. And that is why fossil fuels, why renewable energy, which is everything, even nuclear, is about somewhere between 5 and 10% of all the electricity we use on the planet. So, it's not making us independent of fossil fuels. So we still need to do a lot of R&D, and that'll take 10 years before we have viable alternatives to fossil fuels. So we have the bottleneck of copper and magnets. That is a real bottleneck. So we haven't run out yet. So we can do short term, which is nuclear, which will heat the water not with fossil fuels, but with uranium. Heat the water, turn the turbine. It will use copper wires, etc. But what we can do is take the electricity plants we have now, the furnace, the boiling water, the turbines, the copper wires, etc., and simply replace the gas burner with a nuclear burner to heat the water. Because we only have to change the fire, not all the rest of the installation and the whole grid which is attached to this electricity plant. So a quick way to make us independent or more independent of fossil fuels is taking our existent power plants, who are burning coal or burning gas or burning oil, burning fossil fuels, and replacing the heat part of it, the part where you boil the water, and replace that with something which is not fossil fuel, like nuclear. But they're experimenting with rust and all kinds of other things. You can generate heat, thermal, taking the heat from the ground. And in that way, we could make an energy transition, at least to get off of fossil fuels by using our existing power plants, but heating the water in a different way, not with gas and oil. So that will be smart. So we need to rethink. We don't need to build a lot of wind turbines, which cost a lot of money and cost a lot of fossil fuels and cost a lot of materials. If we could just replace the cooker, the way you boil the water in our existing gas power plants, and we can use the whole infrastructure, because we don't have to replace a gas heating power plant with totally replace it or build it somewhere else. We have all the infrastructure, all the electricity lines and stuff like that. So the thing is, we need to use our brain to, on the short term, make us less dependent on fossil fuels by changing and reusing our existing infrastructure and just being smart about it, and not wasting our money on wind turbines and all kinds of turbines, building new turbines which cost a lot of money and are not going to make us independent from fossil fuels. So, but there's a third way. It's not a solution, but there is a third. Well, there are actually two other ways in which to generate electricity. That's what we call the fuel cell. That is, it works with a chemical reaction. So you have a square box, and in the middle you have a membrane, and in one part you put H2. Oh God, what's English name for that? I'll have to figure that out. In one part you do H2, and the other part you do water, and you get through the membrane, which is made of chemical of a certain kind of material, which invites the oxygen molecules to migrate, and the H2 is turned into H2O, and suddenly you have a big a square box in which you have a lot of water on two sides. But you started out with H2. Oh God, I don't know the English name for that. I'll have to, you look it up. And so that's what they call a fuel cell. And when the oxygen molecules migrate from one side of the membrane to the other, that creates electricity because it moves the neutrons inside a wire. Now, is it nitrogen? No, that's something else. Anyway, you take the H2, in Dutch we call it waterstof, but to make that, you have to first use electricity to create a chemical reaction which separates water into H2 and O, oxygen. And then when you want electricity, you put the two elements together again with the membrane in the middle, and you end up with electricity and water, H2O. So in a way, a fuel cell, because it takes electricity and energy to create the H2, in fact, the fuel cell or the H2 is just a way of storing energy. So H2 is a liquid which stores energy just like gas or oil, only you don't drill it out of the ground. You have to chemically make it. They're talking about green. Is it hydrogen? I think it is hydrogen. They're talking about green hydrogen, sort of like we can pump the H2 out of the ground. It naturally exists, but there's not a lot of it, and we don't have done our homework on that. So fuel cells are great for electric planes and cars and stuff like that in the future. But it will be a part of the energy transition, not our savior or, the Holy Grail. And then what is really exciting is they're working on a membrane which works on photosynthesis, which is what plants do. Plants have a leaf, and the sun shines on it, and the water in the leaves reacts with the sunlight. It takes the energy from the sunlight, and it changes the chemical composition, because it takes the nutrients from the ground, and it mixes it with water, and through the chemical reaction, which is powered by the sunlight, they create sugar. And you sort of go, what? Well, sugar is what drives my muscles. Everything inside of me moves. My muscle cells contract with the energy they get from the sugar. So there are ways in which you can make sugar with sunlight in a chemical reaction, and then there are ways you can use this sugar to make a chemical reaction to make electricity or any other kind of product. So actually, photosynthesis, and plants are 100% efficient with that, is a wonderful way to convert energy and to create material, because, a plant takes nutrients from the ground and water and sunlight, and it builds leaves and fruits, and it creates matter we can eat, but it turns it into something material. So if we could do that, if we could do what plants do, but in the lab or in the factory or even outside, that will be amazing. And they're up to 15% efficiency, and they're working on it. It's really in its infant, but photosynthesis, which is the most efficient use of the solar energy on the planet, and all our plants do it, is really a very exciting technology. And so there's a lot going on, and there are some other ways in which we create electricity, etc. So there's a lot going on, and I'm really very positive about this, and we're really smart, and a lot of universities are doing projects and designing. So if we pour in the money, then we will get there, and we'll get there in 10 years. And we will be able to be independent from fossil fuels, or even if we reduce our dependence by 50%, it'll be amazing with the fertilizer and the plastic and all the other stuff. So So I'm optimistic, but what we have to do is stop buying assets and have a financial economy and use 90% of our profits in investing in these kinds of developments. And in 10, 15 years, we will be using a lot less fossil fuel. And with all this cheap renewable energy, our economy will boom. The bottleneck is the fossil fuels, and only a few people, a few companies are taking all our profits. If we could do this, oh man, we could all be rich. And there will be so much profit to share among all the people. So I'm really positive, but we need to invest. And then they go, yeah, but we have nuclear fusion. Yeah, all the money. It's a ploy by the fossil fuel companies who lobby to have the government put all their money, billions and billions and billions, into nuclear fusion because they know it's not going to work. It's not going to work for another 30 to 50 years. Nuclear fusion is a black hole in which all the money we could invest in cheap renewable energy is sucked. So the government is basically burning our money to heat the water, to turn the turbine, to make the stick turn, and the stick has the magnet, and the magnet's inside the copper wire, and we have electricity, and there's your light bulb. Well, there we go. We need to convince our politicians and our political parties and our scientists to make a plan, execute it, and make our companies spend 90% of their profit on research and development on renewable cheap energy and materials and fertilizers. I'm going to explain batteries in the next video.